Hi everyone. For the rest of Module 4, we're going to talk about trigonometry, and this is a very important topic actually. Now the word trigonometry means, well technically it means the study of triangles, but we are going to really focus on right triangles. Beginning trigonometry really becomes the study of right triangles. So we're going to study right triangles, we're going to add to, we've already worked with some right triangles, we're going to add to it. But let's talk about labeling a triangle. So we know that every right triangle looks like this. You have a right angle, which is this one right here. Opposite the right angle, you have the hypotenuse. We've used that word a lot this year. And then the other two sides, for now we just call legs. We have two legs in a right triangle. They're the two sides that are not the hypotenuse. Well, the first part of trig is being able to talk about those two legs separately. Like we want to be able to differentiate between the two. But like right now in the picture, one of them is green and one of them is pink. So I could say, okay, let's talk about the green one or the pink one. But in math, we don't want to say green and pink. We want to be able to differentiate and talk about one leg versus the other. So to do that, we are going to use the fact that a right triangle has two, not counting the right angle is 90 degrees. The other two angles are always less than 90. And in fact, they always add up to 90 because there's 180 degrees in a triangle. If 90 of them are used on the right angle, then there's 90 left over for the other two. So if the two of them together add up to 90, each one separately has to be less than 90. So they are definitely both acute angles. They're less than 90 degrees. Now, a trigonometry problem is about one of the two angles. It doesn't matter which one, but you have to know which one you're using because it changes. So once you've decided which angle you're using in the question, let me give you an example. In our last section, we talked about a 30, 60, 90 triangle. So the two acute angles were the 30 and the 60. I can do a trig problem using the 30, or I can do a trig problem using the 60, but I have to know which one I'm doing because I'll get a different answer depending on which angle I'm using. So we are going to differentiate this way. Let me put this all up here so we have the picture. Okay, so once you decide which angle you're using in the question, so here's a right angle, and I said this angle right here, x, whatever it is, I'm not even going to put a number in, whatever it is, that's the angle I'm using. Now once you decide that, we're going to name the two legs. We're going to call one of them the opposite leg, which means opposite from that angle that I'm using. And then the other leg we're going to call adjacent. The word adjacent means next to or connected to. So of the two legs, once you pick your angle, remember the angle comes first, because this is a whole different question if I'm talking about this angle up here. But since I'm talking about that angle in the lower left corner, I'm going to say opposite would be opposite from that. So the opposite leg is over there on the right, and then adjacent or connected to that angle is the one on the bottom. So let's start with this. Here is just an ordinary right triangle. There's no numbers. I don't know how long any of the sides are. I don't know what any of the angles are. And let's just start with this. If I was using angle P in a trigonometry problem, which side would be opposite, which side would be adjacent, which side would be hypotenuse? Now what I'm going to do is I'm going to start with the hypotenuse because that's the one that never changes. It doesn't matter what angle you're talking about. We have a definite, rigid definition of the word hypotenuse. The right angle in this picture is Q because it's got the little box in it. From the right angle, if you go to the opposite side of the triangle, you will always find the hypotenuse. So that one never changes. You don't have to worry about that. Now the other two sides are legs, but again, we want to be able to differentiate between the two. So we want to decide which one is going to be opposite leg and which one is going to be adjacent. Now to do that, I have to use this fact right here. So I told you in the question, the angle I'm using in the question is P. Now maybe I'm using it because there's a number there, maybe we know P is 20 degrees, or maybe there's an X here, it doesn't matter. We're using angle P. Once you realize you're using angle P, the opposite leg means opposite from angle P over here. So the bottom down here is going to be our opposite leg. And then, kind of by process of elimination, when I'm doing this, I usually find hypotenuse first because that's easiest, find opposite because it's opposite from our angle, and then whichever one is left over is adjacent. Although really what adjacent means is, adjacent means next to or connected to angle P, which it is. All right, now just to show you why picking the angle is important, let's repeat the same example, but we will use angle R instead of angle P. So now all of a sudden in my question, I'm using angle R. Maybe the X is down here. Now the one thing that doesn't change is the hypotenuse. Q is still the right angle. This is the one I said I always find this first because it's easiest. Hypotenuse never changes. The ones that might change are opposite and adjacent. So if I'm using angle R, then that means opposite is over here. And then for this one, adjacent would be down here on the bottom. So these names are going to be very important for us. You can't do a trig question without understanding opposite, adjacent, and hypotenuse. Just remember, hypotenuse is easy. We know how to do that. We've been doing it for a long time. Opposite and adjacent have to do with which angle you're using in the question. Find opposite first, kind of save adjacent for last, is what I usually do. Okay, so a trigonometry problem is going to involve making ratios or fractions out of two of the three side lengths. So in a trig problem, you're going to have a triangle. Maybe you know all three of the sides. You're going to pick two of them, and you're going to make a fraction out of them. Now our three trig functions, or our three trig ratios, are named sine, cosine, and tangent. Those are going to be very important words for us. We're going to be using them a lot over the next couple weeks. Now, when you use them in a question, or when you read them in a book, or when you find the button on a calculator, we abbreviate each one with the first three letters of each name. So for sine, it just says S-I-N. Now, it still says sine. You're not saying sin. I hear people in their first learning trig all the time say sin. It's not sin, it's sine. Same thing for cosine. We abbreviate it COS. It's not cos. There's no math function named cos. COS stands for cosine. TAN stands for tangent. So after the trig function, sine or cosine or tangent always comes in angle. You're never just going to see SIN, sine, all by itself, or COS, cosine, all by itself. It's going to say something like sine and then an angle. Maybe sine of 20 degrees, or tangent of 50 degrees, or something like that. Now the angle that comes after the name, after the trig function, is the one from the problem that you used to find opposite and adjacent. That's what I meant earlier when I said, let's say you're using angle P for this question, or you're using angle R for this question. That's the one you're using. So let's say we had this picture right here. We have a triangle where I labeled some sides. There's a 5, a 4, and a 3. And I labeled the angles. One of them is 36.9 degrees, one of them is 53.1 degrees. So in this question, I might ask you something like this. I'm not just going to say, what is sine? That question doesn't make sense. I might say, what is the sine of 36.9 degrees? That's one of the angles in the picture, and that tells you where opposite and adjacent are. Or maybe in a different problem, or in a part B on the same problem, I say, now find tangent of 53.1. And that's telling you, okay, well now I'm using the other angle. I'm using that 53.1 up on the top right, and that's going to tell you what opposite and adjacent are. So after the trig function, either sine or cosine or tangent, comes the angle, and that's how you know what you're using for the question. So Our three trig ratios or fractions look like this. Number one, sine. Now for the formula, I just put sine of x because it could be anything. It could be sine of 20 degrees, it could be sine of x, or anything. So sine of something, sine of blank, equals opposite over hypotenuse. So remember, we have three sides, opposite, adjacent, and hypotenuse. Each trig function is a fraction or a ratio made out of two of them. So however long opposite is over however long hypotenuse is. Now cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what we have, there's this very common, it's called a mnemonic, which is a memory device. So we have this, not really a word, but this mnemonic, this thing, SOHCAHTOA, S-O-H, so, C-A-H, ka, T-O-A, TOA. So we say SOHCAHTOA, and it helps us remember the trig ratios. Because in each group of three letters, S-O-H, C-A-H, and T-O-A, the first letter gives you a trig function. S stands for sine, C stands for cosine, T stands for tangent. Now the second two letters give you the fraction. So when I say S sine equals, think of this as a fraction right here, opposite over hypotenuse. And then the second one, C cosine equals adjacent over hypotenuse. The third one, T tangent equals opposite over adjacent. So you have a different color here. You have S O H. So C A H ka T O A TOA. SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So let's do this. Let's take a triangle and let's find these three things. Sine of L, cosine of L, and tangent of L. Now notice each question I'm asking you about L. L, L, and L. That tells you which angle you're using in the question. L is up there. And that's what I'm going to use to label my sides. So first of all, before I even worry about L, the one thing I could have done automatically is I could have said, since J is the right angle, opposite from it, that makes this the hypotenuse. So the square root of 65 is the hypotenuse. Then, now, since I'm talking about angle L, that makes the 7 opposite, because it's opposite from L. And that makes the 4 adjacent, because it's adjacent to L, but also because it's the last one that's left. After you find hypotenuse and opposite, the only one that's left is adjacent. So what I want to do now is I want to find each one of these, and I want to do it using SOHCAHTOA. SOHCAHTOA. So let's start with the first one. I asked you to find sine L, and from SOHCAHTOA, sine equals opposite over hypotenuse. So I'm going to make a fraction. Each one of these are fractions or ratios. I look back at my triangle, I say which one is opposite? That was the 7, so that goes on top. Over hypotenuse, which is the square root of 65. Now, we can leave that as a fraction. We can grab a calculator and do 7 divided by the square root of 65. I mean, I'm just going to leave them as a fraction for now. Let's do cosine. Cosine L. So I look back to SOHCAHTOA again. Cosine is adjacent over hypotenuse. So I'm going to make a fraction again. Adjacent is 4. Hypotenuse, same as before, square root of 65. And then the last thing I asked you guys to find was tangent L. And from SOHCAHTOA one last time, tangent is opposite over adjacent. So I'm going to make a fraction again. Opposite is 7, adjacent is 4. So it's 7 over 4. So tangent L looks a little cleaner because it doesn't have that square root in it. But each one is just a fraction. You're just picking the right two sides out of your triangle. You're putting them in the right order. Remember, it's always the first one over the second one. So when it says S equals, or like when it says SOH, it has to be opposite over hypotenuse. If you do hypotenuse over opposite, that's not right. So in order of your three letters, SOH means sine equals opposite over hypotenuse. And then the same thing for CAH and TOA. So for our last example today, I'm going to combine this with something that we learned about special right triangles. And we're going to find the sine of 60 degrees. So let me do this. I'm going to draw a right triangle. And since we're finding sine of 60, I want it to have a 60-degree angle in it. Well, if it has a 60-degree angle in it, what it actually is the 30, 60, 90 triangle that we talked about from yesterday. Now, see, I didn't tell you any of the sides this time. So what we need to do is we need to figure out what they are. Now, we saw a problem a couple times this year where I said, okay, if I tell you that one side of this triangle is twice as big as the other, then you call one of them x, and that makes the other one 2x. That would be twice as big. Well, if you remember, that was the relationship between the shorter side and the hypotenuse. So if the shorter side is x, I'm going to call this side right here x, then the hypotenuse is 2x. It's twice as long. So all I need now is the longer leg, the third side of this triangle. And the rule for that is if you know the shorter side, which is x, you can multiply it by the square root of 3 to find the longer leg. So this one is going to be the square root of 3 times x. So we're using what we learned yesterday to set up the sides. Now in my picture, the 2x is definitely the hypotenuse because it's opposite from the right angle. If I'm asking you to find sine of 60, that means the 60-degree angle is the angle I'm using in this problem, which means this one is opposite. And then again, by process of elimination, this one would be adjacent. So let's go. Now that we got our picture set up, let's go back to SOHCAHTOA again. It always comes back to SOHCAHTOA. So I asked you to find sine of 60. And from SOHCAHTOA, sine is opposite over hypotenuse. So I'm going to make my fraction. I look at my picture. Opposite is radical 3 times x. Hypotenuse is 2x. Well, what happens is those x's cancel out. So you have a fraction. If I have x on top and x on bottom, they cancel. And my final answer is just radical 3 over 2, or square root of 3 over 2. So that's going to be our answer here for SOHCAHTOA. That's it. Like in the first example, I asked you to find sine, cosine, and tangent of an angle. You don't need to do all three for this. All I asked you guys, if you look at the question right here, all I asked you guys this time was for sine. So I might just ask you for one like this. I might ask you for all three. But either way, it always comes back to SOHCAHTOA. You got to use SOHCAHTOA to figure out which ratio we're talking about. Sine is always opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent.